Alright, I thought for today we'd just go over a couple more examples on graphing from the vertex form that we did last time. Got a couple questions about graphing some of the points, so we'll just go through 3 more examples here to help you guys through it. We have the steps up here in the order that we want to do them, alright? So we'll just go through this equation, and then eventually we'll get our graph. So first, does it open up or down? In order to find that out, we need to find what A equals. Well, A is always right in the front. It's whatever's in front of the parentheses. So it's a negative sign. That means that there's an invisible -1 there, so A equals -1, which means this will be a down parabola. Finding the vertex. Remember, in our vertex form, we have y equals A, x minus h squared plus k. And our vertex is hk, with h, remember, having its sign changed. So in this case, h is 1, k is 2, so our vertex will be -1, comma 2. And then we can go ahead and graph that. Graph that point. Next, we want to find the axis of symmetry. Remember, the axis of symmetry is just the x-coordinate of the vertex. So I'm going to draw a dotted line on x equals -1. Then we want to find the y-intercept. So to find the y-intercept, what you do is you set x equal to 0 and solve. So y equals negative, plug a 0 in for x, and then continue solving. One squared is 1, and then you tack the negative onto it. That is in the front of the parentheses. So you'll eventually get y equals +1. So that means that the y-intercept is at 0, 1. Remember, the y-intercept will always be at x equals 0. So just on that y-axis, that's where our y-intercept goes. Then we want to find the reflected point, okay? Remember, for the reflective point, you just look at your y-intercept, and you count the distance from the y-intercept to the axis of symmetry, and then you just go over that many spaces on the other side of the axis of symmetry. So you can see our y-intercept here is 1 space away from the axis of symmetry. So that means that the reflective point is going to be 1 space away, but on the other side. And then you always want to make sure you write down that reflective point. So this point is at -2, 1. Finally, you want to find the x-intercepts. For that, what you want to do is you want to set y equals 0 and solve for x. Alright, so first thing we'll do is subtract 0 on both, or subtract by 2 on both sides, excuse me. And since our goal is to get x by itself, I'm trying to get everything over here besides x over here. I'm going to divide both sides by -1 to get rid of that negative sign right there. So we get 2 equals x plus 1 squared. Remember, opposite of the square is the square root. So you get plus or minus the square root of 2. Because remember, when you take the square root of something, you have to do plus minus, equals x plus 1. So I get 2 equations from this. You get a positive radical 2 equals x plus 1, and you get a negative radical 2 equals x plus 1. And you need to solve both of those equations. So the square root of 2 is 1.4. So 1.4 equals x plus 1, and -1.4 equals x plus 1. In both of these, you're subtracting 1, So on this side, you get x equals 0.4, and for this bottom one, you get x equals negative 2.4. So those are your x-intercepts. One would be right here at 0.4. The other one would be right there at negative 2.4. And there would be your parabola. This last step is probably the most challenging just because you need to remember that eventually you get this plus minus part after you take the square root. But the process of solving that like an equation is exactly the same every time. Next example. Again, we want to find if it is up or down. A in this instance is negative 2, because negative 2 is right at the very front, so this is a down parabola. We want to find the vertex, which is hk. H is minus 1, k is plus 1, but remember h, the sign changes. So the vertex is at 1, 1. So right here. Axis of symmetry is the x-coordinate of the vertex, so x equals 1. I'm going to draw a dotted line there. Y-intercept, set x equal to 0, solve for y. So y equals negative 2, 0 in for x, and continue solving this. Negative 1 squared is positive 1. Negative 2 times 1 is negative 2. So y equals negative 1. So 0 and negative 1 is the y-intercept. The reflective point, remember you just count from the y-intercept to the axis of symmetry, and then that same distance on the other side of the axis of symmetry. So from the y-intercept to the axis of symmetry is 1. So that means that there's going to be a point 1 away from the axis of symmetry, but on the other side. And then that point is at 2, negative 1. Finally, we want our x-intercepts. So plug 0 in for y, solve for x. First thing you do is subtract by 1 on both sides. I'm going to divide by negative 2. So you get 1/2 equals x minus 1 squared. Take the square root because that is the opposite of squaring. So plus or minus radical 1/2 equals x minus 1. So from here, we're going to set up two equations because we have a plus minus here, which makes two different equations. So, excuse me, we have positive radical 1/2 equals x minus 1, and then negative radical 1/2 equals x minus 1. So, get your calculator, take the square root of 1/2, which is 0.7. So 0.7 equals x minus 1, negative 0.7 equals x minus 1. To solve both of those equations, you add 1 to both sides. So you get 1.7 equals x, and then 0.3 equals x. And then you just plot those points. So 1.7 is here, 0.3 is here, and finish your parabola.